In this lesson, we're going to discuss the network topology. A topology is a graphical depiction of the layout of a computer network. There are two different types of topologies. The physical topology describes the layout of the network or how devices are connected. A logical topology describes how devices communicate with each other or how data is transmitted on the network. It's important to know the difference between the physical and logical topology because different types of networks may use one type of physical topology but use an entirely different logical topology. The physical topology refers to the way a computer network is physically wired. There are different types of physical topologies. A bus topology is created when the computers are all connected to a single cable. A ring topology is created when one computer is connected to another, and then another, until they form a ring. Think of the physical topology like the roads in a city. If we were to look at a map of a city, we could see all of the interconnecting roads. This is the physical topology of the roads in our city. Each road connects different buildings to different parts of the city, much in the same way cables connect devices to each other on a network. The physical topology doesn't necessarily dictate how data is transferred between computers. The way data is transferred is dictated by the logical topology of the network. Consider this house on this map. This is the street that connects to our house. This is also known as the physical topology. The logical topology dictates how data is transferred on the physical topology. By way of our analogy, the logical topology is similar to the traffic laws that dictate how traffic flows on a physical road. Now suppose these streets are one-way streets. Right here are traffic lights, and over here is a roadblock. These components make up the logical topology of our map. They control how cars can drive on the roads. With the network, the logical topology describes how the data travels on the network from source to destination. This means two different networks could have the same physical topology, but have completely different logical topologies. For example, suppose we have two networks that share the same physical topology. This is known as a star topology. All the devices connect to a central connecting point. This network could have a logical topology that functions in the same way that a bus topology functions. Its physical topology is a star topology, but its logical topology is a bus topology. By way of contrast, this network could have a logical topology that functions as a star topology. In this case, both the physical and the logical topologies are star topologies. Let's review the different types of topologies available. Let's begin with the bus topology. All devices are physically connected to each other by a single central cable. Suppose this computer wants to send some data to this computer. In a logical bus topology, the data is sent to all the computers connected to this central cable. Each computer looks at the data it receives and determines whether it's addressed to them or not. If it isn't, it discards the data, and if it is, it accepts it. Now let's look at the ring topology. In a physical ring topology, there is no central connecting point. Instead, you have point-to-point connections between network devices. Each device is connected to the device before it and after it. So within a ring topology, each device is connected to only two other devices. In a logical ring topology, data is forwarded along the network by each computer. For instance, if this computer needs to send data to a computer on the other side of the ring, it sends it to this computer first. Then this computer checks to see if the data is for it. And since it isn't, it forwards it to the next computer in the ring. The computers keep doing this until the data reaches its destination. If computers that are directly connected send data to each other, it goes directly to that computer and doesn't need to be forwarded. Older networks use this topology, so you probably won't encounter deployments that use both physical and logical ring topologies today. A physical star topology uses a central connecting device, and all the devices on the network connect to this central connecting device. This is the most commonly used physical topology today. With logical star topology, data is sent directly to the intended device only. For example, when this computer wants to send data to this computer, the data is first sent to the central connecting device. The central connecting device then analyzes the data and forwards it to the intended computer. Logical topologies can be implemented on top of a different physical topology. For instance, a physical star topology can use a logical bus topology. In this case, data from one computer would be sent to the central connecting device. The connecting device would then duplicate the data and send it to every computer connected to the device. Each computer would then look at the data and see if they are the intended recipient. If they aren't, then they would discard the data. With the mesh networking topology, each device on the network has a point-to-point connection to every other device on the network. In the example, each of these 4 computers has a direct connection to the other 3 computers. With this topology, the more computers you add, the more connections you need. Until recently, the mesh topology was theoretical. In order to create the point-to-point connections between every computer on the network, each device would need a separate network adapter for every other device on the network. For example, if you had 50 devices on a network, each device would need 50 network adapters. This provides tremendous redundancy. A failed link can be compensated for by using redundant links. For this reason, this type of topology may be implemented on a network backbone. However, it is rarely implemented on a production network with workstations. The number of network interfaces required make this topology impractical to implement. However, if we use a wireless networking medium instead of a wired medium, the mesh topology becomes practical. If these connections were changed to a radio signal using a wireless network adapter, we would only need 1 network adapter in each of these devices. Each wireless network adapter can communicate directly with the wireless network adapter on any other device. You may see a partial mesh topology. In this topology, some nodes are connected to all the other nodes using direct links, but some are only connected to 1 or 2 other nodes. This is less expensive and more practical to implement as compared to a full mesh topology. However, it offers far less redundancy than a full mesh topology. In this lesson, we learned about network topology. We learned that there are 2 topology categories. There's the physical topology and the logical topology. The physical topology describes the way networks are physically wired, and the logical topology describes the way that the network transmits data and operates.